Hey everybody, this is Larry. Oh yeah, this is the last day of the month. How does that go? Celebrate something, something, something. Oh, yeah, another month down. Everything's Gucci, and yeah. Today I just rest because tomorrow I have a 5K, so today is another rest day. I would say maybe I really did need that rest because I've been kind of I think I was, and this is maybe a lesson in general, is to take breaks. I know that there's like this streak culture, and honestly, I really think this streak culture is kind of harmful. I have a video on this. I think. Did I push that video? Let me look for it. Let me see if I have it. Hang on. But basically, if it's on, then I will. I will just say go watch it. Oops, that's the wrong link. Hang on. Hang on. Sorry, friends. Oh yeah, I do. I did publish that one. I did have a video that I'll post on the comments. Actually, it's called "Let's Go Streaking." But my point there is that especially on these like daily streaks, and it doesn't really matter. First of all, right, effort level is different. For me, I might have a long streak, whatever today is, right, but we're all at different places, right? It's like me going to the gym and doing bench with a 5-pound dumbbell or something, right? Like, yeah, do I have a dumbbell streak? I guess, but it's just like not an interesting streak because it's not challenging. You're not growing. You're not getting bigger. You're not getting stronger. You're not improving yourself, right? And I would say a lot of these videos, I am not improving myself. And I'm not saying this to brag or anything like that. I don't know if that's a brag, but it's just, like I do it for kind of for fun. I do it for the videos and all these things, but and then the other thing is, you can define these streaks. It doesn't have to be a daily streak. It could be, weekly streaks, right? Maybe like a 5-day a week for a 1-week streak and so forth, right? It could be a lot of different things. It doesn't have to be, it doesn't have to be how people box you in, right? And I think there was a comment on yesterday's video because yesterday was a tough day for sure for Leetcode, right? Is that like you end up we just come on, you copy and paste, and then you never not learning. Is that really count? What is the streak? What do these streaks do, right? And for me, I think I am at the same way, and for me it wasn't for that reason. I would say for my because I got injured 2 weeks ago. On my shoulder, so I've been just kind of doing a lot of rehab stuff, but maybe I should have rested a little bit more. I just haven't been sleeping well again, but that's another story. But so the last couple of days I've been just resting a little bit more and not push myself too hard. Like I do a couple push-ups here and there, but nothing too major. And hopefully, my body just catches up, and you finally learn or something, right? Anyway, I do have a video about that, so let's take a look at today's problem. We have 1680 concatenation of consecutive binary numbers. Given an integer n, return the decimal value of the binary string formed by concatenating the binary representation of 1 to n in order, modulo some big number. Let's do, right? Okay. And n is pretty big, so you cannot. Oh, actually, can you? I was going to say you can't do it reasonably, but you can't just do a for loop. But actually, maybe you can. I mean, we just keep on modding, right? Yeah, I think you can. I mean, it's annoying, and it's probably cutting it close, to be honest, because... No, I mean, I think that's fine. Yeah, so it's just a for loop. It's a weird for loop, but it's a for loop, right? So maybe you would write something like... What is the best way anyway? So maybe you have like, well, we'll start at 0, right? So current is equal to 0, where for I in range from 1 to n plus 1 to be inclusive. And then I don't know if this is the quickest or quick enough way. I don't care if it's the quickest way. but I don't know if this is the quick enough way. So this gives you the binary number, right? And what does this mean? And maybe we don't even need this actually. We just need the number of bits to multiply it, right? Because basically what we're doing, and it is kind of awkward, is that we take this number or some subset of the number, we convert it to binary, we shift, and then we convert it back to decimal, right? So we could do that without needing to know this, though we should get the number of what is it called, like log 2 of. I'm not gonna lie, I never know exactly. Like I know it's log base 2 or log base e. I always forget. Let me Google search for it. Math.log base, right? Python. I always forget if it's log base n or log base 2. Yeah, it is in. Oh, huh. I actually didn't know that there's a 2. Though I don't know if this is precise enough for what I want, to be honest. But okay, let's do it for now. Well, actually, I mean, you can certainly do this, but one thing that we can and actually take advantage of is that we're going from 1 to n, 1 to n, right? And what that means is that 1 has 1 bit, 1 binary bit, 2 has 2 bits, 4 has 3 bits, right? Or yeah, and so forth. So when this makes a transition, right? So we could just take advantage of that, and then we could just shift by that much. So then maybe we could say last power of 2. We'll just say you go to 1, right? So then now we go current, we shift, and by shift I mean we times it by the last power of 2 that we use, right? And then after we shift, we add I, right? And then if I is a power of 2, and there's some like power of 2 tricks, you can write something like this, right? Something like this for power of 2, and maybe you want it before actually. And I think that would work. I mean, you have to mod it, of course, and I knew that, but I think this or something like this would work. Let's give it a quick spin. I mean, we want to go up to 12, which I think is probably good enough, but because 12 is still a random enough number. So yeah, so that looks pretty okay. So this looks pretty fast. This is a pretty tight loop now that we're kind of doing all the math. And let's give it a quick submit. And yeah, we look pretty good. Probably you could be, or I could be a little bit faster, but that's fine, execution wise, and I could probably just do the code a little bit faster. But yeah, I think it's just about recognizing the pattern of you're doing everything from 1 to n. Because the way that I broke this problem down is that, okay, well, I think the first step is just can we simulate this, right? And initially I thought that we couldn't, but then just thinking about it a little bit more, I was like, oh wait, no, you can, because it's just 10 to the 5th. You can write a for loop from 10 to the 5th, or from 1 to 10 to the 5th. Each operation that I knew that you have to shift. Shift is a multiplication. Add addition is an addition. So it should be fast enough. So I did that, and I go, well, how many steps how do we shift it, right? How many times do we shift to the left? And that's just, well, initially I thought that, well, that depends on the width, the bit width of the current number. But then I was like, okay, well then now we have to do this function to calculate for every number. And then the next step was, okay, well, can we do it a little bit faster? And yes, it's because you're doing all the numbers, so it's going to be monotonically increasing, and only increase at those, well, powers of 2s. And that's it, right? And then we just have to remember to mod. And because of mod, this multiplication is constant, right? Because, yeah, keep in mind that this last is just at most 10 to the 5th, or the last power of 2 before that. This is ads. So everything is pretty tight, pretty fast. And yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. I'll see y'all later and take care. Bye bye.